Hello, this lesson is on direct variation. We'll go ahead and start with a quick warm up just to review. Does the graph represent a proportional relationship? Anytime the graph goes through the origin, 0, 0, it does represent a proportional relationship. So that's how we know. Just look at the origin. All right, so in this lesson, today I will solve problems involving direct variation so that I can determine if sets of data have direct variation. I'll know I got it if I can write the equation to represent direct variation relationships. How do I determine the constant of variation and write a direct variation equation for a given situation? All right, so this is academic vocabulary that you should already have. It's also in ClassKick under the notebook. You have proportional relationships, unit rate, constant of proportionality. This is what we're covering today. Direct variation shows a relationship where y changes the same rate as x. Rate of change, how fast a number changes compared to another number. For example, how much distance you cover in a certain amount of time. All right, so let's see if we can watch this video real quick.
Y is directly proportional to x. If y equals 30 when x is equal to 6, find the value of x when y is 45. So let's just take this each statement at a time. Y is directly proportional to x. That's literally just saying that y is equal to some constant times x. This statement can literally be translated to y is equal to some constant times x. Y is directly proportional to x. Now they tell us if y is 30 when x is 6, so y is 30 when x is 6, and we have this constant of proportionality, this second statement right over here allows us to solve for this constant. When x is 6, they tell us y is 30, so we can figure out what this constant is. And we can divide both sides by 6, divide both sides by 6, and we get this left-hand side is 5. 30 divided by 6 is 5. 5 is equal to k, or k is equal to 5. So the second sentence tells us, this gives us the information that y is not just k times x, it tells us that y is equal to 5 times x. Y is 30 when x is 6. And then finally they say find the value of x when y is 45. So when y is 45, we have 45 is equal to, so this we're just putting in 45 for y. 45 is equal to 5x. Divide both sides by 5 to solve for x. We get 45 over 5 is 9, and 5x divided by 5 is just x. So x is equal to 9 when y is 45.
All right, so that was a good explanation of that. Let me go ahead and move on. So we've got the note page here. What is direct variation? Words. A direct variation is a proportional key. It's a proportional note. We know that it goes through the origin relationship in which the ratio of y to x is constant. That's that k, that constant of variation. So this really should look familiar. We've already been talking about this. The constant of proportionality is also the constant of variation for direct variation. Y equals k over x, and to find k, you divide y by x. So that's your note page. That's also in ClassKick. So it says solve each direct variation problem if y varies directly with x and y equals 12 when x equals 4, find y when x equals 7. All right, so now you can start with that, or like in the video, we know that y is equal to kx, and the x value here, we're going to substitute in, the y value is 12. We're just going to replace that y with 12. And then the x value, when y is 12, x is 4. So it's 4k. And so to find k, you're going to divide by 4. And 12 divided by 4 is 3. So k, our constant of proportionality, is 3. Okay, so then it says find y when x is 7. So let's start with that equation again. I think was supposed to be writing down here. So we're going to say that we know K now, and it tells us X is 7, so we're looking for Y this time. So the K value is 3, the X value is 7, so it is 21. Now, another way to look at that, you can actually write this, remember Y over X. So the first one was 12 over 4, and now we have this second one is 21 over, this is equal to 3, and then that second one, the Y value is 21, X is 7, and it's 3. So constant, it is a constant. All right, that should cover that. Let's go ahead and go on to the next one. So how about this one? Solve each direct variation problem if Y varies directly with X and Y equals 6 when X is 12, find Y when X is 18. Now we can do the K is equal to Y over X if you prefer that. And so we have the Y is 6, X is 12, and that reduces to 1 over 2, or 0.5. So then we'd want to find Y when X is 18. We now know what K is. So we know we're trying to find Y. So we substitute the K 1/2, or multiply that by 18. So Y is equal to 9. And maybe you already realized that when you saw this is 6 over 12. And so if that's remember is Y over X. And so if the X value is 18, then the Y value should be 9. Don't overthink this, all right? Do not overthink it. All right, so writing a direct variation equation from a table. So now the input is always your X value, your output is your Y value. So this is X, this is our Y. So with the 2 is here, this would be 1.5. And so then that would simplify. You can use your calculator if you need to. 1.5 over 2 is 0.75. So 0.75. And then 3.75 over 5, and you can do the math there, is also 0.75. And then the 9 over 12, when you divide that, it's 0.75, and so on. That all comes out to 0.75. This one's kind of, you got that decimal over 19. So it's constant. Remember, the K is equal to Y over X. So the equation, here's our form. Here we are going to just put in the 0.75 for our K, X. That's it. All right, let's try this one. So we have the width and length. So we're going to do X over Y. The table shows the widths and lengths of the United States flag. Determine whether the data set shows direct variation. Okay, so we need to test some points. So we're going to do Y over X. So this one, 0.95 divided by 0.5 is 1.9. And so the next one, you're going to do the 2.375 over 1.25. Right, it was over 1.25, and it's 1.9. So if you check all of these, then they're all going to come out to the 1.9. So it is a direct variation. Our equation should be in this form. This is the k when we did the y over the x. So all it simply is just 1.9x. What about graphs and direct variation? So remember the key, the direct variations are all proportional. So it has to go through that origin, and it has to be y equals kx. All right, not this. And in the next unit, we're going to learn about these types of graphs and those equations. So has to go through the origin. So the amount, let's try this one. The amount Ben earns, Y, varies directly with the number of hours he works. So here's his earnings, and here's the number of hours. Write a direct variation equation. Identify the constant of variation. So you can just do this one. Remember, it's just going to be y over x. K is equal to y over x. Y at this point is 5.5. Our x value is 1, which just simplifies to 5.5, and that is our k. So you just write that as 5.5x. So the answer here would be C. All right, we're going to do a couple more. We may run out of time. Let's see. Let's go ahead and do this one. So Trailblazer Inc. is known for making high quality suits. If they take 9 days to stitch 90 suits, how long will it take them to complete an order of 180 suits? So if you are saying this is our X, this is our Y, and it really for this problem, it doesn't matter as long as you are consistent. If the suits is Y, then this suits has to be Y. So if I do y over x, that's my constant, a variation, I'm going to do 90 over 9, which means they can do 10 suits in the day. That's our constant. So I know what the 10 is, and this, remember, the suits is y, so I can do 180 is equal to 10x, and you divide by 10 to solve it. And x is equal to 18. All right, and just y'all can pause the video on this and try this one on your own. And let's do one more. So Acela Express, the fastest train in Washington D.C. and Boston, covers a distance of 455 miles in 7 hours. How many miles will the train travel in 4 hours? So we'll make this our x, y, again, as long as you keep it consistent. So our k is y over x, and in this case we're doing 455 over 7. Miss Horton does not know exactly what that is, so we'll go to the calculator. 65, so k is 65. And we have our y equals kx. So now we know this time they're giving us 4 hours, which is the x value. So we're trying to figure out what y is. So we're going to do 65 times the 4. So that should be 260. You can use your calculator, but that should be the answer. All right, so here's your week. Make sure you are completing your assignments. This is the direct variation assignment. There is an OMS quiz. If you need help with that, just reach out to me or with anything.